Hello everyone, welcome to my channel Nerdy Coder. If you're the first time seeing my video, please give me a like and subscribe and share this video with others. This will give me more motivation to create new videos for you. In today's video, I'm going to show you how to use MongoDB with your Express.js application. In my last video, I showed you how to use MongoDB and run queries against MongoDB to perform CRUD operations and data aggregation. Before you can integrate MongoDB with your application, it is important to know how to run queries and use MongoDB. So if you missed my last video, I would encourage you to check it out. I'm going to be starting with a basic calculator REST API, which I've been working on throughout my previous videos. I started with a very basic calculator application. I then created OpenAPI document and added data validation on the request and response with this OpenAPI document. And then refactor the application with MVC pattern and use data access object to access data in a database. I'm going to take you through a journey of a simple calculator request so that you have a better understanding of the code which we are starting with today. This is a GET request to localhost on port 3000 on the path calculator. This request is going to return us with all calculations currently in the database. If you go to the code, you can see that Express.js is listening on port 3000. This base path variable refers to a string of /calculator. When Express.js receives a request on the calculator path, it is going to send a request to the calculator router. This calculator router is set up to handle GET method on the base path of calculator. The request does not take any parameter, but the response is an array of calculator result DTO. The router calls this function, and this function essentially calls the calculator controller's getAllCalculations method and respond with the return value of this method. Inside the getAllCalculations method, there are two steps. In the first step, it is calling the calculator DAO's list method. If you look at the function signature of this list method, you can see that it is returning an array of calculator domain object. In the second step, it is converting each calculator domain object in the array into a calculator result DTO using the calculator mappers to DTO method. This calculator DAO is actually an interface with 5 function signatures. Our calculator DAO is currently implemented with a mock calculator DAO class. In each method of this class, we're either reading or writing to the mock DB variable and manipulating the data in memory. As you can see, using MVC pattern increased separation of concern. In order to use MongoDB for our calculator REST API, all we need to do is to implement this calculator DAO with MongoDB. We don't even need to change the rest of the application logic. There are different ways to use MongoDB in our application. You can use various ORM, object relational mapping libraries, to read and write data to MongoDB. ORM libraries allow you to define and enforce schema for your data. This makes it easier to use MongoDB in your application without having to write complex queries. A popular ORM tool in Node.js for MongoDB is Mongoose. Another tool is called Prisma, which supports MongoDB as well as other relational databases, such as MySQL databases. In this video, I will use the official MongoDB driver for Node.js so that you don't have to learn another tool in order to use MongoDB. With the MVC pattern we are using in our calculator API, database access is abstracted behind a data access object. You can use any tool or library to implement this DAO interface without impacting the rest of the application. With DAO, your application won't be tied to any particular ORM implementation. You can choose to use an ORM library now and easily change to a different library later. Let's get started. The first thing you need to do is to install the MongoDB library. You can type npm install MongoDB. If you get an error like mine complaining about the Node.js version, you may have to upgrade your Node.js in order to install MongoDB. As it says here, the minimum required Node.js version is 16.20.1. My Node.js version is 16.17.0. This means that I have to upgrade my Node.js version in order to install MongoDB. The latest Node.js version is 16.20.2. I'm currently using Node Version Manager (NVM) to manage my Node.js version. In my case, I can simply type nvm install 16.20.2. It may be different in your situation, but you can always refer to the Node.js website for instructions to install the latest version if you have this error. Before you can use MongoDB in your application, we need to create a MongoClient from the MongoDB Node.js Driver. I will first create a folder named Services, and then create a file named mongo.ts. I will first set the MongoDB connection string and extract the connection string from an environment variable. In the development environment, this variable will be MongoDB :// localhost : 27017. However, in the production environment, this connection string may be different. By using an environment variable for the connection string, I will have more flexibility in controlling the connection string to connect to different MongoDB instances when this application is running in different environments. I will then create a MongoClient using this connection string. There are other options available to set up the MongoClient, but this is the most basic option to create a MongoClient. The connection string must not be undefined, but any environment variable that you extract from process.env may be undefined. I will set a default value of an empty string for the connection string if it is missing from the environment variable. By using an empty string as the default value, the creation of this MongoClient will fail if you don't provide the connection string in the environment variable, and the application should fail to start. Please make sure that you are setting the environment variable before you start the application. I will also define the MongoDB database and collection names in this file. I will use the enum to do it. For MongoDB databases, I will have a database named REST API. Inside this database, I will have a collection named calculators. I will then use an object mapping the MongoDB database name to the collection names. I want to define these names here so that this becomes a single source of truth for all these database and collection names. Next, I will create a MongoDB calculator DAO class to implement the calculator DAO interface. I will create a file named mongo.ts in the calculator DAO folder. I will copy the code from the mock calculator DAO implementation and modify here. I will first remove those unnecessary code. At the top, I will set the database name and collection name. We're going to create a database schema using a TypeScript interface. I will name this MongoDB calculator data. Underscore ID is a required field in MongoDB document. I will name it the same and use this underscore ID as the ID field of the calculator object. By default, the type of this underscore ID field has a type of object ID. I'm also setting this underscore ID field as optional because this ID may not exist in the domain object until the data is saved to MongoDB. For the timestamp field, I will use a date field instead and assign a type of date. I will name the class as Mongo Calculator DAO. The constructor of this class will take a MongoClient. Inside the constructor, I will first set the database to be REST API by referencing the variable I defined at the top. To use a collection of calculators, I will access the method collection from this database object and provide it with the collection name, which again defined at the top. I will save this collection object as a private variable of this class. Before I start modifying the 5 functions which I need to implement in this calculated DAO interface, I will first modify the 2 important methods which I will need, toPersistence and toDomain methods. The toPersistence function will take a calculator domain object and return a MongoDB calculator data object. For the _ID field, if the calculator domain object contains an ID, I will create a new object ID used for MongoDB. Otherwise, I will set it as undefined. By setting _ID as undefined and saving it to MongoDB, MongoDB will automatically generate an ID for me. For the date field, if the calculated domain object has a timestamp, I will need to convert the timestamp into a date format. To do this, I will create a static method to do the conversion. The toDomain method will convert the database data into a calculator domain object. The MongoDB calculator data object has an optional field of _ID. However, we know that after the data is saved to MongoDB, this _ID field must exist. The MongoDB library provides a utility type with ID to convert our type with _ID being the required field. Instead of the ID field, I now have the _ID field, and instead of the TS field, I have the date field from the persistent data. I will convert the object ID into a string by calling the toString method of the object ID. For the timestamp, I will create another static function to convert the date object into a numeric timestamp. Now, we'll go back to implement the 5 functions that we need to finish in our Mongo calculator DAO class. In the create method, I will first convert the calculator domain object into a persistence object. To insert a document into MongoDB, I will use the collection's insert_one method. The create method needs to return a calculator domain object. However, we don't know what this insert_one method returns to us. If you hover your mouse over, this method is returning an insert_one result. To find out what this insert_one result means, you can trace back into the source code and try to trace it down what properties this insert_one result gives us. But there's another way to find out. You can go to the MongoDB's API reference and do a search on insert_one. And then you will see the return value of this insert_one method. You can click into it and you will find out that this insert_one result gives you 2 properties. One is acknowledged and the other one is inserted ID. It does not give you the inserted document. To find out the inserted document, you can run another query. You can use the find_one command, providing the _ID of the inserted document in the query. You can get the _ID from the response of the insert_one command. This find_one command returns either a document or no. This document should exist if everything goes well. I will give a conditional check anyway. If this inserted document exists, I will convert this document into a calculator domain object and then return it. Otherwise, I will throw an error. Because any of these database operations could fail, I will put them into a try-catch block so that if there's any error in the database operation, you can easily find out which steps may have failed. Since we are likely to catch error from the other methods, I will create a utility function to capture this logic of catching the error. I will name this function handleError. In the read method, I will use the find_one method. I will query based on the ID of the document. Since the underscore ID is an object, I will have to convert ID, which is a string, into object ID. If the result exists, I will convert the result into a calculated domain object. Otherwise, I will return undefined. I will also handle the error accordingly. In the abstract method, I will receive a calculator domain object. I will first convert this calculator domain object into a persistence object. To update a document in MongoDB, you can use either the update_one method or the find_one and update method. We can go to the API reference and see the differences between these two methods. The update_one method updates a single document in a collection. You can see that it takes 3 arguments: filter, update, and options, and returns an update result object. In the update result object, it contains several properties. As you can see, it does not contain the updated document. If you look at the find_one and update method, you can see that this method finds a document and update in one atomic operation. It also takes 3 arguments: filter, update, and options, and returns a modified result object. This modified result object includes several properties. Value is the document which we are going to update, or the updated document. We can also go and check out what options are available in this find_one and update method. There are several options which we will need in our abstract method. One of them is the abstract option. If we set it to true, it will abstract the document if it does not exist. The other option that we will need is the return document option. As you can see, when setting this to after, it will return the updated document rather than the original document. The default is before. Because our abstract method will return the updated document, we are going to have to set this to after. Let's go back to our code. I'm going to use the find_one and update method because this method is going to return the updated document instead of having to run another query to find out the updated document. The first argument of this find_one and update method is a query object. I'm going to use ID in the query. The second argument is the update object. I'm going to update the document based on the persistence object. To update the date, I will use the current date operator to update the date to the current date. The third argument of this function is options. If you remember what we just saw in the API reference, to return the updated document, you have to set the return document option to after. I will also set the abstract option to true to insert a new document if the ID does not exist in the database. This is to make it consistent with the intent of this abstract method. Again, if the result is not new, I will convert the result into a calculator domain object and then return it. Otherwise, I will throw an error. I will also handle the error if there's any. For the delete method, I will use the delete_one method to delete the document by ID. I will also handle the error accordingly. In the list method, I will execute the find method without any argument. This will return all documents from the database. An assumption which I'm making here is that I don't have a lot of documents in the database, and I can return all documents at once. But if I have a lot of documents in the database, I will likely need to use some kind of pagination to return a subset of the document at a time. This find method returns a find cursor. To convert this to an array, I can use the toArray method. I will then convert each document in this array into the calculated domain object. I will also handle the error accordingly. This completes the implementation of the Mongo Calculator DAO class. In app.ts, we were creating a mock calculator DAO object in our previous code. Instead of using the mock calculator DAO object, I'm going to use the Mongo calculator DAO object instead. To create a Mongo calculator DAO object, I need to pass in the MongoClient in the constructor. It is now time to test out the updated calculator REST API. Let's make sure that MongoDB is currently running. I'm using Docker to run my MongoDB instance so that I can check by running Docker PS. If you remember when we created the MongoClient, we are taking the MongoDB connection string from an environment variable MongoDB underscore URI. Before you start the application, you have to first set the environment variable with the MongoDB connection string. You can do that by running export MongoDB underscore URI equals MongoDB :// localhost 27017. This will temporarily set the environment variable MongoDB underscore URI with the MongoDB's connection string. And then you can run npm run dev. If you don't want to set the environment variable every time you want to run the application locally, you can hardcode the environment variable in the startup script in package.json, like so. Now, let's test the create method. You can see that it's throwing a 500 internal server error and a message saying that the response message must be string. If you look at the server log, you can see that the error was generated by Express Open API validator, and the validation is on the response. If you remember in our previous video, we used Express Open API validator to validate both the requests and responses. It looks like that the message attribute is not a string. Let's check the data in MongoDB and see how the data looks like. You can see that in MongoDB, the message attribute has a value of null. Since this is an addition operation, the message should have a value of undefined. This attribute should not even be saved in the database. It looks like in MongoDB's insert1 method, when the message has a value of undefined, MongoDB saved the message attribute with the value of null. This is not what we want. Let's check out the API reference and see if there's any option to ignore undefined value. As you can see in the options of this insert1 method, there's an option called ignore undefined. This may be useful for us. Let's see what it says in the document. It says that serialize will not emit undefined fields. Note that the driver set this to false. We are using the Node.js MongoDB driver, and the driver is not ignoring undefined by default. If you set this to true to tell the driver to ignore any undefined value, MongoDB should not include any undefined field in the document saved in MongoDB. Let's give it a try. You can try to create a calculation again and see if it works this time. You can see that we can now successfully create a calculation. I will remove the document with message equals null from the database so that it won't cause any problems later. We should also include this option when we update a document in MongoDB. The find1 and update method also have the same option. I will also set ignore undefined to true for the find1 and update method. I will now test other API endpoints. The get calculation by ID endpoint works. Let's try the update calculation by ID endpoint. You can see that it is giving us a 500 internal server error. It says there's an error in upsert calculator for this ID. Updating the path date would create a conflict at date. Let's go back to the code for the update method and see what happens. The reason for this is that in line 66, the calculation persistence variable includes an attribute called date. And in line 67, we're trying to set the date field with the current date. MongoDB is complaining that we're trying to update the date attribute twice in the same update operation, and therefore creating a conflict. There are two ways to fix it. One way is to update the date field in the calculation persistence variable and not using the current date operator in MongoDB. Another way is to remove the date attribute from calculation persistence, and we can continue using the current date operation in MongoDB to update the date. I will use the second method. To remove the date attribute, one way is to use the omit method from a popular JavaScript library, Lodash. I will install it as well as its type definition. In the code, I will omit the date attribute before passing the calculation persistence variable to the set operator from MongoDB. Let's try to update the calculation again and see if this works. And now it works. Next, I will try the delete method. This works as well. I will quickly create several calculations and then try the get all calculations method. And this works as well. You have now successfully added MongoDB to Express.js. You can also see that by using an MVC pattern in your application, it is very easy to add a database implementation to your application. If I want to use a different database for your application, you can change it easily by implementing the calculator DAO using a different database engine without affecting the rest of the application. If you want to learn more about the MVC pattern, please check out my previous video. In this video, you have learned not only how to use MongoDB in your application, but also how to look at error messages, debug, and fix the errors. I hope you have learned something useful, and I hope to see you in my next video. This is the video I wanted to share with you today. If you like this video and find this video helpful, please give me a like and subscribe, and share this video with others. This will give me more motivation to create new videos for you. Thank you for your support. Goodbye and see you in the next video.